Almost every AWS horror story, the leaked credentials, the $40,000 surprise bill, comes down to one service done wrong: IAM Identity and Access Management. IAM controls who can do what in your account. Get it right and you're safe. Get it wrong and one mistake is catastrophic. The problem most tutorials leave you with: they preach security, then attach full admin to everything. This deep dive does it the real professional way. This is the IAM dashboard. Notice the security recommendations right at the top. AWS telling you exactly what to fix. First, the root user. The problem: when you sign up, you get the root account, the email you registered with, and it has unlimited power over everything, including billing. Using it day to day is like carrying your master key everywhere. The fix: lock it away. On the root security credentials page, turn on MFA, multi-factor authentication, so even a stolen password is useless, then stop using root entirely. The real rule: log in as root maybe twice a year and never for daily work. So how do you set up a new account safely? The IAM dashboard hands you a checklist, these security recommendations. The problem it solves: a fresh account is wide open. Work down the list: MFA on the root user, no access keys on root, and create individual users instead of sharing one login. Real example: every person on your team gets their own identity, so you always know exactly who did what. Green checkmarks here mean your foundation is solid. Two words people constantly mix up: authentication and authorization. The problem: being logged in does not mean being allowed. Authentication is proving who you are, your login, password, and MFA. Authorization is what you're permitted to do, decided by IAM policies. You can be perfectly authenticated and still be denied, because authorization is a separate step. IAM handles both, and keeping them straight is the key to everything else. Now we create our first IAM user, and here's where almost every tutorial teaches a bad habit. They attach administrator access to the very first user. The problem: that's the opposite of safe. Do it the professional way, least privilege. Give a user only the permissions they actually need. In the Create User wizard, you set a name, then attach permissions. Real example: a new analyst gets read-only access, not the keys to the kingdom. Start narrow, and widen only when there's a real need. Managing permissions one user at a time doesn't scale. The problem: 10 users who all need the same access means 10 places to update. The fix is groups. A group is simply a bucket of users that shares one set of policies. Real example: a developer's group with the right policy attached once, add a new developer to that group, and they instantly inherit it. Attach policies to groups, put users in groups, that's the clean, scalable pattern. Now the heart of IAM, the policy. A policy is a JSON document that spells out exactly what's allowed. The problem with only using ready-made policies: they're often far too broad. Here in the editor, you see the building blocks: effect, allow or deny, action, like S3 get object, and resource, the exact thing it applies to. Real example: instead of full S3 access, we allow read on one specific bucket. That precision is what least privilege actually looks like. There are two kinds of policies, and knowing when to use each matters. Managed policies are reusable and named. AWS gives you hundreds, and you can write your own customer-managed ones, and they attach to many users at once. Inline policies are baked directly onto a single user or role for a one-off case. The real rule: use managed policies for anything you'll reuse, and inline only for true one-offs. This policies page is your whole library. Roles, the most powerful and most misunderstood part of IAM. The problem: developers hardcode access keys onto servers, and those keys leak. A role is an identity that's assumed temporarily, with no permanent keys at all. Real example: instead of putting keys on an EC2 server so it can read S3, you create a role with that permission and attach it to the instance. The server gets temporary, auto-rotating credentials. Roles over keys every time you can. Roles also solve sharing access safely, across services, or even across whole accounts. The problem: how do you let something act on your behalf without handing out passwords? A role has two parts: a trust policy, which says who is allowed to assume it, and a permission policy, which says what they can then do. Real example: a role another team's account can assume to read just one bucket. They get in, do that one thing, and nothing more. That is assume. Role. Here's the gap that breaks beginners: how AWS actually decides. The problem you'll hit: I added an allow, but I still get access denied. The roles in order: everything is denied by default, and explicit allow grants access. But an explicit deny always wins and overrides any allow, and guardrails like permission boundaries or organization policies can cap it even further. So when access is mysteriously blocked, look for an explicit deny or an account-wide policy, not a missing allow. How do you know your policy is right and not secretly over-permissioned? The problem: most people never check. AWS gives you tools for exactly this. The policy simulator lets you test, can this user do this action, before anything breaks in production. Access Analyzer, shown here, flags resources shared too widely, like a bucket open to the internet. And Access Advisor shows which permissions a user has actually used, so you can trim the rest. Verify, don't assume. A word on access keys. The problem, long-lived keys, are the #1 thing that leaks committed to GitHub pasted into code. The professional habits only create a key if you truly need command line access. Never put it in your code or repo, rotate it regularly, and prefer roles, which need no permanent keys at all. On this page, you can see each key's last use date. If a key hasn't been touched in months, delete it. In a modern way that almost no tutorial shows, IAM Identity Center, formerly known as SSO. The problem, creating an IAM user for every single human doesn't scale, and it isn't the current best practice. Identity Center gives people one secure sign-in, often tied to your company directory, with temporary access across all your accounts and no long-lived keys. AWS's guidance today is clear. Use Identity Center for human logins and plain IAM users only as a fallback. Let's lock in the Day 1 checklist, what to do on every new account. Lock away the root user and use it almost never. Turn on MFA for root and for every user. Create IAM users or Identity Center logins instead of sharing root. Give least privilege, only what's needed. Use roles, not long-lived keys. Never commit a secret and rotate the ones you have. And set a billing alarm so there are no surprises. Do these, and you sidestep the mistakes behind nearly every AWS breach. Each service we secure has its own deep dive, so subscribe to VOncloud, and we'll keep making AWS simple and safe with real examples.